Ladies and gentlemen, as we continue section 5.5, remember that the directions in the previous problem said factor completely. Our first step in factoring is always to take out a greatest common factor. In this particular expression, the greatest common factor is a z squared. In parens, that leaves me with 64z squared minus 49. Factor completely means go as far as you can. 64z squared minus 49 is the difference of two perfect squares. 8z in the front, and in the back we have a positive 7 and a negative 7. So what I'm pointing to right here is the final answer, factored completely. Look at the trinomial 9z squared minus 24z plus 16. Our first step in any factoring problem is to look for the GCF, and in this particular case the only GCF is a 1, which is basically pretty trivial. If you have a greatest common factor of 1, it means you probably need to look for a different method to do the problem. Well, here this is a trinomial, and remember that a lot of trinomials started as the product of two binomials. So we're going to kind of use FOIL backwards. 3z in the front, which would give me 9z squared. Negative 4 times negative 4 in the back gives me a positive 16. And to make sure I have the correct middle term, chin and grin it. The chin is the inner part. Negative 4 times 3z is negative 12z. The grin is the outer part. That would also be a negative 12z. So the outer and the inner, the chin and the grin, give me negative 24z. And when something is multiplied by itself twice, we simply express it as squared. So this is actually an example of a perfect square trinomial, because it was a trinomial that factored as a perfect square. Here's another trinomial. My first step is to look for the greatest common factor, but again in this case it's a 1. Because it's a trinomial, we try to write it as the product of two binomials. I'll try 8a and 8a in the front, opposite of b and opposite of b in the back. If I want to make sure the middle is correct, I chin and grin it. Chin is the small part. Negative 8ab. Grin is the outer part. Negative 8ab again. That gives me negative 16ab, so I know it checked. And if I want to write it in a succinct form, I can write it as 8a minus b quantity squared. Whoops, too far. Sorry guys and gals. Let me move it down a little slower. Okay, we're getting there. Alright, be patient with me. Got it now. Okay, this problem is an expression that we're trying to factor. The first thing we look for is our GCF. Our GCF in this particular problem is an XY, because XY is the greatest common factor that can be removed from all three of these terms. In parens, I'm left with a 4x squared plus 12xy plus 9y squared. Factoring completely means go as far as you can. I leave the xy alone in the front. This trinomial is going to be reversed or written in a different form, in a factored form, by kind of using FOIL backwards. 2x and 2x give me the front term. 3y times 3y gives me the last term. And if I chin and grin it, 6xy is the chin. 6xy, the larger outer part, is the grin. 6xy combined with 6xy add together to give me 12xy. So I know I've nailed it. And the one last step is to write the thing that's multiplied by itself twice as a squared. All right. a cubed minus ab squared is an expression. Our first step is to take out the a, which is the GCF. Inside the parens, it leaves me with a squared minus b squared. But notice this is the difference of two perfect squares, a plus b times a minus b. So that's the completion to that example. 3x squared plus 14x plus 8. You look for the greatest common factor, which is a 1. Because this is a trinomial, you try to reverse it with FOIL. 3x times x goes in the front to give me 3x squared. I'm going to try a 2 and a 4, both positive, to get the positive 8 in the back. And when I chin it and grin it, I know I've nailed it. The chin part is 2x. The grin part is 12x. 2x plus 12x gives me 14x. X squared plus 25 is prime. No work to it. Remember what we've talked about earlier, and we're just confirming it? The sum of two perfect squares is prime. You're not going anywhere with that. Now, this example is different. This is a subtraction problem. This is a perfect square, and this is a perfect square because the front is AB times AB. The back is CD times CD. We can factor this since it's the difference, i.e. subtraction, of two perfect squares. One sign's a plus and one sign's a minus, and we're done. What I tell my in-class students, and for those of you that are my web students or my SPY students or the hybrid students that are learning from these videos, two things about factoring. Always remember to take out the greatest common factor as your first step. And the second thing is, the more time you spend on your homework and quizzes practicing, the better off you are. And this may even be a good time to go to to look up the textbook homework and use the online book to do some textbook homework. Always remember, the Learning Commons has a ton of factoring problems. You want to get good at factoring. And you don't get good by watching. You get good by doing. Okay?